today we are gonna do another question, which is the magnitude of two vectors are equal and the angle between them is theta. Show that show that there I'm not sure if this is the there or it's THERE. So just choose the one that is right. So that the resultant wait. The magnitude of two vectors are equal and the result angle between them is theta. Show that their resultant divides the angle equally. I find this question very confusing, so let's what? The magnitude of two vectors are equal and the angle between them is theta, so that the result divides. I think it's not so, but I think it's so. So that um, so that the resultant divides the angle equally. What is the angle theta? I changed the question to make it much more legible. Um, so wait. No. The question was right. I think yeah, the question was right. So I just got confused by the wording. Um, so the magnitude of two vectors are equal, and the angle between them is theta. Show that their resultant divides the angle equally. So we must show that the resultant divides equally. Um, so if I have to represent this in a picture, um, let's make a vector. This is my vector. Let's make it white and a lot more thicker, and obviously there will be another vector of equal magnitude, so this looks like pretty equal to me. And um, let's make the use the parallelogram law. So let's make it this dotted line about that big, this color, and something like that. It looks nice. And also let's make the resultant red, and the question states that this is theta, and let's call this phi. Let's call the red vector as vector r, the white vector as vector a, and the blue vector as vector b. I'm just assuming that this, and according to the question, we know that the magnitude of vector E is equal to the magnitude of vector B, and we have to prove phi is theta by 2. So we must prove this. So yeah, I think that's pretty easy. Um, Also, wait. Let me tell you something. If you wanna do this a little bit more logically, um, you can see it in the picture. It also looks pretty sensible to me. And if you wanna do it a pretty logically, think there is a rock over here. If you pull it here and here with equal strength, there isn't a place that where you pull with more strength, like right? So there is not extra force over here, so that the resultant would actually dip down. So if A had a bigger magnitude or a longer magnitude, then I would assume that the resultant would drop down in some angle, but um, in respect to A, but it does not. So wait, it does not when they both are pulling equally. Does that make sense? I'm not sure if that makes sense, but I hoped it makes sense. I think to prove this, we must probably find a relation where phi and theta are involved. And if you ask me, I only remember this relation, which is tan phi. So we are taking with vector A. Obviously, even if you take it with vector B, you will get the same result. Since this is 5 theta by 2, then this angle would also be theta by 2, which means it would also be phi. So tan is sine by cos. The angle which I am making with is A, and this will be the formula. Let's just keep the values that we know. Um, just by looking at this, I think this might be uh, very straining for me when doing it mathematically. But let's see. Let's hope it's not that hard. So I'm letting A and B be equal to X so that it is much more easier for me to handle. So, and if you take X common, you can obviously cancel the X from the top and bottom. So you will get tan phi equals sine theta by 1 plus cos theta. Now what should I do? So if you got here and you are stuck, it's a pretty simple way to solve this now. You must have learned a little bit of trigonometry. I think that will make it a lot more easier for you, but still I will teach you. So we have sine theta, and we have a formula which is sine theta equals 2 times sine theta by 2 cos theta by 2. So this piece right over here is equal to sine theta. Why? That's something that you have to learn. Like, it's a proof. You can obviously prove it, but this is not math class. This is like physics. So not gonna teach that over here. And also, 1 plus cos theta is actually 2 cos squared theta by 2. So this portion right over here is actually equal to 1 plus cos theta. Pretty neat, right? So we have this, and let's just look at the top and bottom. The 2's will cancel out, and the cos, one of the cos theta by 2 will cancel out the bottom one. So we have sine theta by 2 by cos theta by 2, which means tan phi must be equal to sine theta by 2 by cos theta by 2. So sine by cos is tan, so tan theta by 2, and which means just looking at these angles, this looks like phi is equals to theta by 2. So let's write the conclusion. Since phi equals theta by 2, it proves that the resultant divides the angles, and I think that the angle equally. So this was a pretty fun question, if you ask me. Like, even I got confused for some while. I don't know what that tells me about myself, but or tells you about myself. But that was it for today's video. So in the next video, we are gonna do another question. So till then, bye bye.